This lesson is for FST, lesson 5.4, on the inverse sine. The inverse sine has also in the past been referred to as arc sine. Symbolically, when you do the inverse sine, you do sine, and then it looks like it's being raised to the -1, but that simply indicates the inverse. And you can find that easily on your calculator. Remember that when you're working with an inverse of an equation, you switch x and y. Or if you're doing it graphically, you reflect the original graph over the line y equals x. Let's look at a word problem involving inverse sine. So let's read the problem. A plane is flying at an altitude of 6 miles and begins its descent to the airport when it is 100 miles away. At what angle of depression does the plane approach the runway? Remember that for the angle of depression, it always goes from a horizontal downwards. So when we're drawing our picture, we've got our airplane flying, and it's going to have a downward angle as it goes towards the airport. So here's the angle that we're trying to find. So the airport is over here. Obviously it's going to be down at the bottom. It's 100 miles away, so our 100 is here, and the 6 miles is the altitude, that is the height between the plane and the ground. So that's going to be 6 here. Now I want you to, since we're focusing on sine today, I want you to use the sine trig function to try to figure this out. So we would need to have the hypotenuse value available. So because we need this length, we would have to use the Pythagorean theorem. So we do a squared plus b squared equals c squared. I want to know what just c is, so I take the square root of 100 squared plus 6 squared. So when I do that, I get 10,036. When you do the square root of that, you get about 100.18. So that's the value of the hypotenuse. So now if we're going to use sine to solve this question for the angle, the angle that's here, the angle of descent, so we would do the sine of the angle is, for SOHCAHTOA, it's opposite over hypotenuse. So in this case, that would be the 6 over the 100.18. And we would have to do the inverse sine of that whole problem in order to get the value of theta alone. So you'd simply type that in degree mode on your calculator, the inverse sine of this fraction. And when you do that, you should get a value of about 3.4. Now if you think about that value, you want that number to be low. As you're descending in an airplane, you don't want to go at a steep angle, otherwise that would be highly uncomfortable. We will revisit this problem again when we do inverse tan in lesson 5.6. Let's talk a little bit more in depth about the definition of the inverse sine function. If you look at the blue graph here, that's the original sine function graph. And if we reflect it over the line y equals x, we get the red graph here. Notice that the red graph will not pass the vertical line test, so we restrict the domain to be just from pi over 2 to negative pi over 2. So we're only going to look at the graph from here to here. So here they've highlighted that portion of the graph only, from negative pi over 2 to pi over 2. So there's the original sine graph. If we look at the domain and the range of that graph, it's going from negative pi over 2 to pi over 2 in the domain, and just like always, it goes from -1 to 1 in the range. Now if you flip just that portion of the graph over the line y equals x, you get the new red line. So that is the graph of the inverse sine function. And that's the one that you want to draw on your paper and record in your notes. Notice that when you do the inverse of something, the domain and the range switch. So now the domain is from -1 to 1, and the range is now negative pi over 2 to pi over 2. So when you're thinking about working with an inverse of sine, basically we're only working with, on the unit circle, we're only working with values in quadrant 1 and their opposites. So we're only looking at values from -90 to 90. So what I usually tell kids to focus on when they're working with an inverse sine is think about a value in quadrant 1 or its opposites. So quadrant 1 and its opposites. So if you're anywhere else on the unit circle, you're going to want to try to reflect it somehow into quadrant 1 and either do a positive or a negative value there. So now let's apply that to some problems involving inverse sine. Keep in mind that when you do the restricted graph here, there were those 3 values that we talked about when we first did the inverse cosine. 3 things that have to occur in order for that to be maintained. So those are given in your book. we're going to look at baby calc questions that involve inverse sine. So again, on these, they give you a location, you're going to have to find, or excuse me, they give you an exact value, and you're going to have to find the radian or the degree measure that goes with it. So you're trying to find where on the unit circle the sine will have a value of square root of 2 over 2. Hopefully that one is familiar to you. Square root of 2 over 2 always occurs when the value ends in a 5, and hopefully you all know that when we're dealing with an inverse sine, we want to do values between negative 90 and 90. This is a positive value, so I want to be in quadrant 1 only. The only place where I have square root of 2 over 2 for sine is at 45 degrees, or if I'm in radians, I would say pi over 4. Those are just two that I have memorized. They may also ask you the question in arc sine form versus inverse sine form, but know that those are interchangeable. So if I have negative 0.5 or negative a half, I want to think about where on the unit circle the sine value would be a half. If I look at quadrant 1, the sine value is a half right away at 30 degrees. If I'm at negative 1/2, that would be down here in quadrants 3 or 4. But I'm not allowed to be in those values or those areas. So I want to think about where negative 30 would be located. Negative 30 would be down here. That'd be the same as saying positive 330. But if I say negative 30 now, that's a value within the restricted domain. So I figured out where I was in quadrant 1, and then I just took the opposite of it. So I'm going to say it equals negative 30 degrees or negative pi over 6. Again, that's a value of radians that I've simply memorized. And the last one, here you're taking the inverse sine of the sine of 5 pi over 4. If you don't know where 5 pi over 4 is, you're going to need to convert it to degrees. So let's quickly do that. 5 pi over 4, you convert it to degrees, you multiply by 180 over pi. Pi's will cancel. Doing some reducing here. Divide by 2 here, I get a 2 and a 90. Multiplying, I get 450 divided by 2, which is 225. So I'm trying to find the inverse sine of the sine of 225 degrees. So first focus on the sine of 225. I know that that's going to be in quadrant 3, and I know that the value there is going to be negative square root of 2 over 2. So now I still need to do the inverse sine of that. So I've got inverse sine of the negative square root of 2 over 2. I know that square root of 2 over 2 is, if I flip that back into quadrant 1, it's going to be at 45 degrees. And because it's negative, I want to say negative 45 degrees. So the only values that I'm allowed to give here are between negative 90 and 90. So I know I'm at 45, but because it's negative, it's going to say negative 45, which puts me down here in quadrant 4. And if they ask you to give it in radians or degrees, you'd want to have that answer available as well, so negative pi over 4.